Hi there. This is Chapter 3, and I wanted to go over a long problem for summary statistics. So this is another one that we did in a face-to-face class. So here is the following is a sample of 10 Seahawks ticket prices for Sunday's game versus the 49ers. So here is my picture. Here's StubHub, and I went through this and I got a bunch of different ticket prices. So here is the sample of ticket prices. And this, I'm going to make this a smaller font because the numbers are getting weirded out. There, that's better. So $397, $450, $908, $1054, they're getting more expensive. $1377, $1781, $1943, $2590, $4046, and $12,012. Since I got this sample, the ticket prices have actually gone up, and now the maximum ticket price is more like $16,000. So the pressure's on. Here is a whole bunch of questions that you should be able to find the answer to. Find the mean ticket price. Find the standard deviation of the ticket price. Find the variance, the median, the range. What is the z-score for a ticket price of $2,000? Is this price an outlier? Find the 25th percentile. Find the 40th percentile. Find the IQR, the inner quartile range, and interpret it. Write the 5-number summary and draw a box plot. And finally, use the box plot to describe the shape of the ticket price distribution. Is that it? Yes. So this is sort of an example of all the questions I could ask you about a sample of numbers. First thing to keep in mind when you read a problem like this, the following is a sample of ticket prices. So this tells us that these numbers, yes, are a sample. So these numbers do not represent a population, they represent a sample. If you go to this thing, there's many, many tickets you can buy. So the 10 tickets that I put out there, they are just a sample. So to find all this information, you're going to want to use your calculator. So you do this, you hit the stat button, and then you hit edit, and then you type in all the data into L1. Then to find these statistics, you're going to hit the stat button again. Then you want to go to one variable statistics. It should be right there waiting for you. You hit second function. That would be a 2. Second function, L1. After you hit one variable statistics, it'll be blinking. So you hit second function, L1, enter, and then your calculator will give you a whole bunch of numbers. So because your calculator gives you all these numbers, all of this, answering all these questions should go pretty fast. So first one, the mean ticket price. This is a sample mean, so we use X bar, and the sample mean ticket price is $2,655.80. So again, you get that from your calculator, X bar. The standard deviation of the ticket prices. So because this is a sample, how do you know it's a sample? Because I said the following is a sample of 10 ticket prices. You use SX in your calculations. So your calculator gives you SX and sigma, the population standard deviation, but in this case, you're just going to use S of X. So your calculator gives you the sample standard deviation, and the calculator writes it as SX equal to 3,463.66. You can use 2 or 3 decimal places. I'll tell you on a test, but 2 is fine for the purposes of this problem. To find the variance, it's going to be the sample variance. So this is S squared, that's the variance. Your calculator does not give you the variance. That is one number that the calculator does not give you. So you have to actually take this number, you have to write it down on your paper, 3463.66, and then type it in again and square it. And when I did that, I got 11,996,1,940.60 as the variance. The variance is hard to interpret. That's why we usually talk about the standard deviation. So the average ticket price is $2,600, and a typical deviation from this is about $3,000. So there's a pretty wide range of ticket prices. The median ticket price, your calculator also gives you the median, is 1,579. In this case, did I put these numbers in order? Yes, I did. That was clever of me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median is going to be right here. The number that splits it's going to be right between 1377 and 1781. So the median is 1,579. The range is defined by the maximum value minus the minimum. So in this case, the maximum is $12,012, and the minimum was $397. It better be some nice seats for $12,000 a seat. So the range of ticket prices is $11,615. What is the z-score for a ticket price of $2,000? Is this price an outlier? So the z-score, I'll make this a little bigger for you. The z-score is the observation minus the mean divided by the standard deviation. So in this case, the z-score, the observation we're saying is 2,000. Subtract the mean. We found the mean up there was 2655.8. And divide by the standard deviation, again the sample standard deviation, 3463.66. You do this and you get a z-score of minus, right here, 0.189. So this number is close to 0. It's not an outlier. It's more of an average number. And you can see that a ticket price of $2,000 is sort of close to the mean price of 2,600. So it's not a particularly unusual ticket price. Find the 25th percentile. In this case, what you want to remember is that the 25th percentile is also the first quartile. So the first quartile, your calculator gives you that. It's $908. That's the easiest way to do it, is to look at what your calculator gives you as the first quartile. If you want to do it the hard way, you could say, well, the data set here, the middle of this data set, because this is the lower half of the data set, and the middle is 908. I guess that wasn't that hard. So that's right there is the lower quartile. And if you look at the upper half of the data, the middle number, 2590, is the upper quartile, or Q3. So here's a question asking for the 40th percentile. So the 40th percentile, this is a little tricky. You say the trick here is to notice that there are 10 numbers. So each one is a 10th percentile. So this is 10%, 20%, 30%, 40%, 50%, up, etc. So we would say 4/10 of the numbers, or 40% of the numbers, are less than or equal to 1,054. So these 4 are all less than or equal to 1,054. So 1,054, or 1054, is the 40th percentile. And suppose I had asked for something harder, like what is the 44th percentile? That would be a lot harder. So for the purposes of a small data set, I'm going to make it easy for you and have it be a percentile that's easily divisible by the number of data points. Find the IQR and interpret it. The IQR is the inner quartile range, and it's defined by Q3 minus Q1. So the third quartile minus the first quartile. So in this case it was 12,590. Remember this one? Oops, didn't mean to do that. This one minus 908. So the IQR is 1682. So again, that's the third quartile minus the first quartile. And to interpret this, we say that the middle 50% of ticket prices cover a range of $1,682. So if you need to interpret the IQR, just spit out a sentence that looks like this. We say that the middle 50% of the blank, whatever your data set is, in this case it's ticket prices, covers a range of, and then you put the IQR in there, 1682. Write the 5-number summary. The 5-number summary is minimum, Q1, median, Q3, and maximum. So again, your calculator gives you these numbers in order. Use the arrow key after you spit out the numbers to get down there and see the extra quartiles. So the 5-number summary looks like this: 397, 908, 1579, 2590, 12,012. Draw a box plot. Okay, this is when it gets fancy and lovely. So here is the 5-number summary. If I'm going to draw a box plot, make sure my sizing is right here. So this doesn't have to be perfect, but I'm noticing the numbers go sort of from 400 up to about, 12,000. So I'll try to just do it the best I can. That's 400, 500, 600, 700, 800, 900, 1,000. I'll put 1,000 there. 1,100. It's going to take me a while. 1,200, 13, 14, 15, 16, 17, 18, 19. Okay, 12,000 is going to be way down here. So my scaling's off, and it's okay if yours is off on a test also. So this is 400, 500, 600, 700, 800. Do you see how 12,000 is going to be off the scale? But 397 is going to be down there. You put the minimum. 908 is about, see, that's 900, 800, 900. So 908's just a little past, just basically 900. Ooh, 1,500. 11, 12, 13, 14, 15. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We'll call this 25. 100. Okay. Again, your box plot is likely to not be to scale also. So you take these 3 numbers in the middle, and you make a box out of the 3 in the middle, like this. Your box will almost certainly be more beautiful than this box. If I was really fancy, I would be using that box tool there, but I'm not going to be that fancy. And then it goes out, way, way, way out here. So this number is 397. This is 908. This is the median, 1579. This is the Q3, 2590, and way off in the distance you would see 12,000. Okay, I'm going to draw a better one for scale. So this would be more like 3,908, like this. So 397, 908, exciting, isn't it? Up here we have 12,590. The median's closer to this side. It's like this. 1579. That's the median. That's the middle number there. And then 12,000 would be more like this. Way, way out here. And then there's something like that. This is 12,012. So I like this second box plot better. So. And if you go back to this problem, draw a box plot. Great, done, perfect. I think my box plot nailed it. Use a box plot to describe the shape of the ticket price distribution. So this box plot, which is no good for describing the shape because you can't even see that last tail, but this one, if you did the scale right, you could see that this tail is very, very long. So because this, sometimes they call it the whisker, because this long whisker is to the right, you could see that this distribution was right skewed. Right skewed. So that answers the question here. Use the box plot to describe the shape of the ticket price distribution. The answer is right skewed because of the long right whisker. Because of this whisker, we know it's right skewed. So that is how you would answer all of those questions. Again, you really want to use your calculator or you're going to be doing a lot of hard calculations, mainly for the standard deviation. So hope that helps you answer a question like that for the test.